Hi sir, good morning. My name is G. Kiran Kumar. My roll number is 2195180473 and I am from ECE section B. And my topic is semiconductors and its applications. Semiconductors and its applications. Introduction. A semiconductor is a material that can, under some conditions, conduct electricity but not others, and typically a solid chemical pot or a compound, making it a strong electric current control medium. Its conductivity depends on a control electrode's current or voltage, or its infrared IR, visible light, ultraviolet, or X-rays. Intensity radiation. The unique characteristics of a semiconductor depend upon the added impurities or diagrams. Similar to the conduction of the current in a wire, an n-type semiconductors mostly holds the current in the form of negative charge electrons. A semiconductor of form P is primarily assisted by electron shortcomings known as holes. A hole has positive electric charge equal and opposite to the electron charge. A halo flow occurs in a semiconducting material in a direction opposite to electron flow. Antimony, arians, boron, mercury, germanium, selenium, silicon, sulfur, and terranium are elementary semiconductors. Silicon is the most known, providing the base for the most integrated circuit. Gallium arsenide, indium antimonite, and the oxides of the most metals are popular compounds or semiconductors. Gallium arsenide (GaAs) is typically used in low noise, high gain, low signal application. Silicon is used Silicon is used in electric circuit manufacturing and in solar cells, laser diodes, etc. Gallium arsenide is used. Some compounds are not suitable conductors, metals, or insulator glass. Semiconductors are considered a material that has crystalline from that has very few free electrons at room temperature. Its resistivity lies between the driver and the isolator. Regulator conductivity may be produced when sufficient impurities are applied in the semiconductors. A few case silicon, germanium, carbon, etc. Semiconductors. The basic block of modern electrons includes transistors, solar cells, LEDs, and digital and analog integrated circuitry at Simeon. Semiconductor applications in electrical equipment. Semiconductors are materials conducting electric current that can be controlled easily and act as insulators as well as semiconductors. ES futures have enabled semiconductors in electronics. All about us are semiconductor chips. They can be found from the family car into the pocket calculator in almost every commercial product that we touch. Halfway systems are present today in the wide variety of sectors, including computers, transmission system, aerospace, construction, agriculture, and healthcare. Semiconductor has decreased the size, cost efficiency, and durability of electron devices such as MP3 players, HD TVs, CD players, computers, and mobile phones. Solar cell semiconductors application technology. Much of solar cell absorbs the photons in symmetry. Materials nowadays, as the result of charger generation and the subsequent separation of the photo produced charging carriers. The semiconductor layers are the primary components of the solar cell and the core component of the solar cell. There are various semiconductor materials for conversion of energy of photons in the electric energy. Telecommunication uses of semiconductors. As a result of the need for quick knowledge delivery, the telecommunication sector is rising bigger than ever. The fiber optic transmission soon becomes the foundation for the transfer of audio, video, and internet data. The broadband network components experience relevance, research, and develop as this industry matures. This includes lasers that generate VCSEL, edge, film DVD M filters, and waveguides, EDFA and Raman amplifiers, photodiodes, decorators, etc. The functions are also included. Semiconductors used in computers. One of the most important technologies supporting modern computers is semiconductors. They form the basis of all modern electronic devices using circuits. In order to solve vacuum tubing problems used an analog computer, these materials first were presented. The tubes would often leak and electrons would often flame out metals used to transfer electrons inside them. These problems were not faced by semiconductors. The material of all semiconductors conduct electrons totally differently from the materials, thereby stopping them from burning out. Contracted to vacuum tubes, semiconductors had little time to warm up until usage of prolonged periods. Result. Let us go to the conclusion. Result and conclusion. Silicon can be regarded as a carrier of knowledge. There have been two revolutions in the development of information, approximately 500 years apart. First of all, the details given by John Gutenberg in other invention of transistor is open to many. The global knowledge volume is currently doubling per year. We take our gradient many ways, for example, laptops, internets, and cell phones. Without silicons, microelectronics, in vehicles, home appliance equipment, and more computer circuits are also present. Equally important are photoelectronic devices in daily life, such as data transmission, fiber optic communication, data storage. The number of transistors in an integrated circuit grew exponentially over time after beginning of semiconductors electronics. In brief, we have summarized the yearly development of semiconductors and rate. The temperature effects of semiconductors were also explored. With rising temperature, the energy band differences, mobility, threshold voltage, and saturation velocity are decreasing. Conductivity, carrier density, leaks current, and resistance is interconnection rise at higher temperature. On the other side, we have also researched semiconductor application in basic electrical equipment, telecommunications, and wireless networks, and finally in the solar industry. Thank you.